So in this video, I'm gonna try to explain evolution logically as I understand it, and my objective with this is to prove that human behavior and ethics and stuff like that, it's all logical and tied to essentially molecular interaction. So there's no spiritual stuff or stuff like that. So yeah, I'm trying to uh, basically uh, show you a model of the world, a very simple model of the world and how life works. And because it seems everything to have logic and reason, and it just stuff just doesn't happen magically and stuff like that. So I'm gonna start doing a diagram, and we'll see how it goes. I'm doing this stuff like this because I'm doing it live, because if I put a lot of effort into the video, it would take like a month to do a video, and then you would miss a lot of the stuff that I went through. And I would also make very few videos, and it would take a lot of time, and it just seems like this is the better way to do it. Although it's very stressful. I'm not also in the best shape, but yeah, I'm already a little bit fidgety. So yeah, let's start. So we'll start with the atom. So this is the old model of the atom. So the atom doesn't actually look like that, but I'm gonna take essentially this is the old model of the atom. So I'm just gonna take a picture of the nucleus, and this is the nucleus, and then I'll explain a bit about the atom and just superficial stuff. So yeah, so we'll start with this. So let's say this is the atom. I'm saying this this is the atom, but it's just the nucleus. The thing is that the actual atom looks something like this. So the nucleus is very, very, very small there at the center, and then there's a cloud where the electrons might be. A cloud of possibility where you might encounter the electrons. So yeah, this is the old model of the atom with the electrons spinning around the nucleus. So this is one thing, and what I also wanted to show you, the newer model. So depending on the what type of atom it is, what chemical element, depending on that, you have this that big cloud of possibility. It essentially splits into other clouds, and it's smaller, and yeah, this is essentially how it would look. So yeah, but yeah, we'll keep it simple like this. This is the nucleus, but we will say it's essentially the atom. It's just missing the electrons that's somewhere around it. So yeah. So okay, so we'll start with the atom as the basic building block of everything we see in the universe right now. You know, there's dark matter and stuff like that, but yeah, we won't get into that. So yeah, this is not quite straight. So then, I also want to include that so that seems to be too big. What I wanted to show you, that it starts with one atom, but temperature and energy and stuff like that makes them move around, and that sometimes they bond and form molecules. So I'm gonna, that's the next step. So let's use this, or maybe something like this. Wait. So I'll bring this a little bit lower. So the atoms move around, and they bond to each other depending on the chemical properties of each element and stuff like that. I won't explain that because that's chemistry, and I just have a basic knowledge of that. So yeah, this is the next step, the molecule. So, or let's say a simple molecule. Okay. Then stuff keeps bumping around, and you create more complex molecules. So, yeah. So it goes like this. Then something happens, and I'm gonna use this. So you have all kinds of molecules here. I need to chill. I'm getting fidgety. So, things keep bumping around and bonding and forming larger molecules, but these are getting destroyed, by temperature, by radiation, by stuff like that. So they keep getting together, they keep getting split up, and so there's nothing that could survive in time, so there's just small stuff happening, so you don't get to life like that. So the big next step is, so I'm gonna say it starts with the primordial soup. So you kind of need a stable environment in which those molecules don't get destroyed. So it needs to be stable temperature. So this is like a theory, the primordial soup. So it would be an environment in which you have the conditions that life could start in. So yeah. So you have the primordial soup, which would be mainly a water environment in our case. Let's say stable, then so just that water is more dense than air, and bonds and stuff like that can happen more easily. So it's not, chemical reactions in the air are not as often, don't happen as often as in water or stuff like that. So we have this primordial soup, which is basically water, some kind of pond or something. I think very likely somewhere in a cave or something. So yeah, somewhere in a cave or something, and most likely it's somewhere underwater, because sunlight is radiation, and that also breaks down the molecules. So after they formed, they get destroyed by sunlight and stuff like that. So I think most likely life started somewhere devoid of sunlight. And this is an example of something that could provide the energy in the water and also stir up the water to make the chemicals more likely to bond. Because if it's static, if it's just like a lake or something, or if it doesn't have currents in it, and it doesn't have something to stir up the materials inside of that pond, then it's not very likely for bonds to happen. So you need an active environment, like where someone stirs up the pond just for the chemical bonds to happen and create molecules, more complex molecules. So this is a possibility, the hydrothermal vent, which also is heated, which provides the energy, and also provides some elements, chemical elements. And it's a place where life, but it's a place where life could start, but it's you need a lot of them and a lot of time. So it's not as simple as you have one of these and you create life. So back to the diagram. So you have this primordial soup, I think, which is most likely the origin of life, where it's a water environment. You have stable temperature, and what else? You have no radiation or stuff that can break the bones. Let's say, or little radiation, I think. Okay, and in this soup, you can, just a second. In this soup, you can, you have the tools to start making life happen. And I'm gonna explain how I think it started, because it seems extremely logical. So, in this primordial soup, you start how should I say this? To have something that lasts in time. So a molecule that lasts billions of years, or a life form that lasts, that lives for a while at least, and goes on in time through reproduction and stuff like that. To get something like that, you basically need to have a structure that preserves itself. So like a molecular structure like this that actually works on preserving itself. So let's say let's here draw a line. So this is how life begins. So from this point onward, what we have here, but I'll talk in the next video what is considered life. But from this point onward, you would have the tools, you would have the elements and the molecules to basically start life. So what I mean by that is that you have let's see if I can find that again. Yeah, this. So you have very complex molecules that essentially preserve themselves. So you need to get to things like life, you need a molecule or a molecular structure, let's say something like this, that preserves itself, and it preserves how should I say this? So you have a molecular structure that preserves. I don't actually know how to write that. Preserves itself. Now, what are the ways to preserve a molecule? So you have to preserve a molecular structure. So you have self-repair, but self-repair it's actually very complex, and through evolution, I think we start from low self-repair, because that's not the main thing how you would preserve a structure. You would start from low self-repair, and as you continue through evolution, you get creatures like humans or animals that have a lot better self-repair. Like you can start fighting infections, you can heal broken bones, you can have stuff like that. But in the beginning, when you have very simple molecules, it's kind of hard to have a complex self-repair system. So the main thing that actually through which a molecular structure preserves its structure is actually self-replication. So the first is self-replication. So, and to be clear about this, the actual molecular structure is not preserved by the self-replication. But that is not really necessary, because if you make a copy of itself, essentially it's that structure preserving itself in time. So just a second. So if you have this self-replication, you can have the necessary nutrients and stuff like that, the necessary molecules and atoms and stuff like that. You can keep making copies of yourself and that survives. That thing that makes copies of itself survives because, you know, some die to sunlight, some die to high temperature, some die to freezing, some die to acidic environments or stuff like that, you know. Things keep getting eroded. So this is one I want to talk more about. So the things keep getting eroded. So for something to survive billions of years, the main thing that the molecular structure should do is to self-replicate. So you have that at the base of it, self-replication. So when you have that, I think you can start calling it life. But it's I don't know how exactly where to draw the line, but that seems to be clearly where it should start. So if you have self-repair or self-replication, that's basically actually if you have self-repair good enough to repair the whole structure, or you have self-replication, which actually creates a whole new structure. And it doesn't, you know, we evolve now where the copy you make is a little bit different and stuff like that, but basically the core of it is still there. You're still making a copy of, mainly a copy of yourself, you know. How life is today, you don't make an exact copy. You know, and this is another talk for another time, but it's you know, you get competition between life forms and stuff like that, and then actually making something a little bit different than it is when you self-replicate has an advantage. So yeah. So so you have this molecular structure that preserves itself through self-replication and or self-repair. So with this, you can imagine that. So you have something that replicates, a molecule that replicates itself. So then through time, a lot of time, you know, billions of years, that molecule can get more and more complex. You know, and it keeps evolving. Let me. So this is so this is the arrow indicates the complexity. So then you have molecules that self-replicate, and those keep evolving in time, you know, to do all kinds of stuff. Because when they die or some of the copies die, you know, you still have some others alive. And then you start having complexity, you know, not complexity of life forms. So then you have, so let's say started in that primordial soup, but then you start developing molecules that use the sunlight as energy, like plants. And I'm not sure I explained it enough, this self-replication stuff. It's essentially what survives in time is a molecular structure that preserves itself. So it's very kind of simple to understand. You keep making copies of yourself, some will survive, some will not, but you still have some copies left. And then maybe some adapt to a new environment, some adapt to a new environment, a colder environment, an environment with radiation, like with sunlight. And through time, so you get something like, I think the first life forms were, what were the research for this? Yeah, so it doesn't see a lot of information. Paquichetus. 48 million years ago. Oh, this is early. So, from this, I'm not sure exactly which evolved first, Basically, from what I know, you had algae, and that stuff filled the oceans, again, self-replication. Which started using sunlight as a source of energy for their chemical interactions. And so you would then have start getting plants from that. They evolved through plants, I mean. And from that, wait, so you can see me. So I think most likely the first was algae, then mainly. Then from that, plants evolved. Then, or I'm not really sure. But whatever it is, it's still a really big molecular reaction, So let's say how I said it started from a primordial soup. I don't think, but so I think creatures started also there. So creatures, this is more like, it's not algae or algae or whatever it's called. So it's not that, but it's stuff that can move around, more resembling an animal or something like that. So yeah. So let's say we started with algae, then we got also some creatures, very, very small creatures that could eat the algae, and then the algae evolved into plants and stuff like that. Then the creatures evolved to eat the plant as an energy source, and then other creatures evolved to eat the creatures as an energy source. So basically how a carnivore is. But it's all essentially a molecular structure that evolves to do something through billions of years of evolution. So it's very slow, but once you have self-replication, it's just a matter of time. And I know the big thing was the going from a single-celled organism to a multi-cell organism. But again, that I think it's just a matter of time. If you have a stable enough environment for a long enough time, which is active. This is the really complex stuff, because Earth is essentially alive with the tectonic plates. It has a hot inner core. So it's a planet that is essentially alive. I'm not talking alive in this sense. In what I was talking, it's not this molecular structure that preserves itself. It's essentially an environment in which things keep changing, but not too much. Tectonic plates go up over one another and bring stuff from the core to the surface and stuff like that, and it's very active. So it's like stirring up the pot, so for things to happen. So yeah, this is my first video regarding this, and it's my objective, as I think I said at the beginning, is to prove that human behavior and ethics and stuff like that is logical and comes down to this, to the preservation of structure, of a molecular structure. So yeah, it was a lot, and I'm still, as I think you'll see from the older videos, I'm still sick and recovering from it, so I don't have that much energy, and this is very stressful. But thanks for sticking with me, and I hope you learned from this, and I think this really is the cutting edge of knowledge right now, as I think, it makes a lot of sense for it to have happened like this, and for self-replication to be the most important thing in evolution. And yeah, I'll continue with this kind of videos. I'll see how I'll feel. Maybe not so often, but yeah, hope you liked it, and see you in the next one. Bye.